Hello class. Today we're looking at our curriculum review part 10. This is volume of prisms and cylinders. Okay, so again we start with a quote this week. It says, when life's tough, remember you are tougher. Right? So yeah, again we're going through some tough stuff, but it's not anything that we can't handle. Just stay safe and remember to wash your hands. Okay, so let's talk about volume. When we look at our formula chart, these are the formulas that we have. We start off with circumference, we've got area, we've got surface area, and we've got volume. So today we're looking at this one right here, prisms or cylinders. And we know that there's only one formula. Volume is equal to capital BH. And we remember the capital B stands for area of the base, which means inside this B right here, this capital B, it's a variable, and we're going to plug in one of these formulas depending upon what kind of shape we have. Now we have three basic shapes that we deal with in the 8th grade. Rectangular prisms, triangular prisms, and cylinders. And the bases that they will have are rectangles, triangles, and circles. And that's what you got to remember. Okay, so keep that in mind. Okay, so let's dive off into it. Here's our first question that we're going to look at today. It says, what is the volume of this prism? Now when you're finding the volume of prisms, you've got to use some steps. There's 3 steps that we follow. First thing is determine the figure. Determine what is the figure that we have. Is it a rectangular prism? Is it a triangular prism? What kind of a prism is it? In this particular one, and the way we determine that figure is we look at the base. Now we need to remember the base is not always what the figure is sitting on. It could be any side, but what we do know about the base is that they're going to be the 2 sides that are parallel and congruent. In a rectangular prism, you can pretty much use any of them because we've got a parallel side here on the bottom with the top, the front with the back, and the right with the left. Okay, then we determine the formula. Well, we know since we're finding volume of a prism, okay, and this one is a rectangular prism, we know our generic formula is volume is equal to capital BH. Okay, but inside this capital B, we're going to plug in another formula. Now we've got 2 formulas that we deal with. Okay, so when we look back here, we've got for the rectangular prism, base times height, or we also know that this could be length times width. Okay, because some of you are still very familiar with that one. And that's the one that I like. So I'm going to do length times width times the height of the figure. Okay, so we look at the base in this particular one. It's going to be the one that it is sitting on right here. That is our base. So we've got our 5 times 6, and it doesn't really matter which one you plug that into. 5 times 6 times, and then now the distance between the 2 bases. And that's how you define this height. It's always the distance between the bases because sometimes it's not going to be up and down. It may be, horizontal. Okay, so in this particular one, it does happen to be 8. So all you do is you take your calculator, you multiply those together. 5 times 6, which is 30, times the 8 gives us 240. And in this particular one, we don't have a unit specified like centimeters or inches. So we just write units cubed. Sorry, I put a square there, but it's cubed because we are dealing with volume. It is 3 dimensions, so it's units cubed. Okay, so that's how we do a rectangular prism. So let's look at another one. Okay, so in this one right here, we first again determine the figure. So if we look at this one, we'll notice that this one is a triangular prism. Okay, now it's sitting on a rectangle, but the base is actually this triangle over here. Okay, so and the reason why is because there's a triangle here and a triangle here, and those are the 2 sides that are parallel and congruent, which would be the bases of this particular shape. So if we're going to do that, we first determine our formula. So again, we've got our generic formula of volume is equal to capital BH, but now we need that of a triangle, which is 1/2 BH, or BH divided by 2. Okay, so when we look at, I went to the wrong figure. So we start with our generic formula. The volume is equal to capital BH. So volume is equal to, so inside this capital B, we've got base times height divided by 2, and then times our overall height. So whenever we're working on a question like this, when we're using this part of the formula, I've got to look at just the base. And we know that the base and the height of the triangle are going to be the 2 sides that are touched by the right angle. So if we look at that, we've got this is a 12. That's one side touched by the right angle. And then this side right here, which is 16 according to this. Okay, so that becomes our base and our height. 12 times 16. We're going to divide that by 2. And then we're going to multiply that by the overall h, which would be the 10, which is the distance between the 2 sides. Okay, so now you would take your calculator, do 12 times 16, divide by 2, and then times 10, Okay, and that should give you volume is equal to 960. And then again, there's nothing specified here, so it's units cubed. Okay, so now let's look at two last shapes real quick. Okay, the next one is this one right here, and this is a cylinder. Okay, so if we were to look at our generic formula for a cylinder, it says the same exact thing. Volume is equal to capital BH. But we know our base is a circle, so we're going to use this for our capital B. Okay? So we got volume is equal to capital BH. So volume is equal to pi r squared times the h. Now, typically we use 3.14 for pi in this particular problem. That's what we're going to do. And the r stands for the radius of the circle. Well, the radius we know is halfway across. Okay, so the piece of information that we are given is the radius. So we do 8 times 8, and then again we multiply by the height of the figure, which is the distance between the two bases, which in this case is our 20. So now we multiply all this together, and you should come up with an answer of 4,019.2 centimeters cubed. Okay, now this one does have a label specified, so we would use it instead of just using the units. Okay, now those three types of questions were being asked to find volume. Okay, now sometimes you may be asked a question like this. It says find the missing dimension. We may be given the volume, and we're asked to find one of the other pieces that we used to get that. Okay, so again, we start off with the same thing. Volume is equal to capital BH. But in this particular formula, volume is equal to, because this is a rectangular prism, length times width times the height. Now in this particular problem, we have four things I could plug information into. Okay, I can plug into volume, length, width, and height. Okay. Now the volume, we were given that, so we would put in the 1440 is equal to, and I'm given a length, which is a 15. I'm not given a width, which is our x, but I am given a height. Now what you've been trained to do is anything on this side that I can put together, we put it together. So the 15 and the 8, I could put that together. Okay, so 1440 is equal to, and we take our 15 and our 8, we multiply that together. You end up with 120x. Now we know all we have to do here is divide both sides by 120. And you should find out that the value of x is equal to 12, and in this case we do have a label which is meters, and since we're looking for just a single dimension, it's just 12 meters. It's not meters squared or meters cubed, it's just 12 meters. Okay, so that's kind of a review for volume. So what I'd like for you to do is you're going to, just like we've been doing over the last several weeks, you're going to go to the following link, and this is an O instead of a 0. You'll go to this link, okay, and fill out the questions on the Google form that I provided you. Okay, so today we have 4 questions. Okay, 3 of them are multiple choice and 1 of them is short answer. Now, on a couple of these questions, I have some numbers here. Don't pay any attention to the numbers. Okay, they don't really mean anything. It's just where I got the information from. Had that number in there and I didn't feel like taking it out this time. Okay, so you've got a question right here. Pay attention to what it's asking for, because it's asking for find the volume of the empty space in the cylinder. Okay, so not the whole thing, but the empty. So you got to kind of think about that for a second. Okay, question number 2. We're dealing with a triangular prism. It even tells you what it is. Okay, so make sure you pay attention to that so you're using the right formula. Okay, then we've got another cylinder. And then last but not least, I've asked you to find the volume of a box, a rectangular prism. So the questions that we have are pretty easy. Okay, so tomorrow we'll talk more about volume, but this time tomorrow we'll be dealing with pyramids, cones, and spheres. Okay, so until then, I'll talk to you later.